Data analysis. In this module, let's go ahead and talk about what we need to know for this domain. Now, this domain here is going to consist of about 23% of the exam, so fairly significant. The main topics will be focused on statistical methods, percentages, testing, and tools. The lessons that are part of the module are focused on descriptive statistical methods, tendency and dispersion, percentages, inferential statistical methods, whiteboard discussions, and we'll talk about regression and correlation, and then analysis testing. We'll then get into a demonstration around analytical tools. We'll then go through a review and some sample questions as well. Let's go ahead and proceed on to the next lesson. Descriptive statistical methods. In this lesson, we want to focus on the descriptive method and understand why it's so important in the world of data analysis. When it comes to descriptive statistics, this is a set of methods that we use to summarize and describe the main features of a data set. We could think of this as like a summary. So if we write a report, we have what's called an executive summary. I like to compare this to that. We're really just putting together an overview of the data and the relationships that that data is part of. There's typically three main accepted ways to approach this. We have central tendency, variability, and position, of which we'll be talking more about these coming up in the upcoming lessons. Now, descriptive statistics can be used, of course, to summarize data, as we know. And the way we want to approach this is typically via tables and charts. So we may want to use a Pareto chart. We may want to use, for example, a different type of a table. We may want to use a plot. Whatever we use, we could consider the method and the approach used to be what we feel is the most effective. Numerical summaries also can work as well. Now, for example, if we have a group of people which we'll call a sample, the sample group, this sample group may have an income that is over $50,000 a year. Well, probably the best way to display and summarize the sample group is via some kind of a graph that visually shows this. Again, it's all about understanding the best way to visualize your statistics that you have so that the viewers of the report can understand what's happening. When it comes to results, as an example, right, the company may use these descriptive statistics to summarize salaries of its employees. Now, this information they may want to use to determine if there is pay disparity. So if we have males and females, again, this is a common thing that you hear about, the pay discrepancy, the difference in pay, right? So maybe that's true, or maybe it's really a myth that you hear. The best way to do that is to do what? To actually take the actual data and run the appropriate analytics processes against that data and visualize it, right? So these are things that can be done in the world of data analytics. When it comes to descriptive statistics, we could, for example, look at housing and urban development. They're an agency in the U.S. that manages housing policy. They collect a lot of data, and they can help, for example, identify areas that need to be improved upon, like police and fire coverage. Even one of the things you may hear about is in urban centers, there may be a lack of grocery stores. We may want to identify income levels, right? This is the data we could use and put together in a form that is descriptive in the world of statistics. So, with that said, let's move on to the next lesson. Measures of tendency and dispersion. In this lesson, let's talk about the common terms and applications. Two very important descriptive statistic concepts that we use are going to be tendency and dispersion. Now, tendency is going to measure the amount of times, is another way to look at tendency, that describe the center or middle of a data set. So if we have a mean or median and we have basically what is called a dispersion around that center, then that is going to be how we want to approach what is called tendency. So dispersion, on the other hand, is going to describe the spread of that data around the center. Now, central tendency is a summary of statistics that represent the center point or value of a data set. This is typically approached by using the mean, the mode, or the median. When we look at dispersion, how do we want to measure that? We're going to want to use variance, standard deviation, or range. Now, in preparation for the exam, I'm going to recommend you spend a good amount of time, like 15, 20 minutes, and review this slide. Make sure you understand the measures here and where to apply them. Now, in preparation for the exam, also expect questions around dispersion and tendency and how to apply what measure. Do you apply the mean, or should you apply variance to actually come up with dispersion, for example? These are things you'll want to be prepared for on the exam. Let's move on to the next lesson. Understanding percentages. In this lesson, let's talk about percentages. Now, when we discuss percentages, it's important to realize two terms and how they work together. First is frequency, the number of times a value will appear. Then percentage itself is the frequency divided by the total number of values in the data set, multiplied by a multiplier, which in this case is 100%. So when we consider percentages, it's important to realize that there's really three specific parts to the formula. This again is testable, so we want to make sure we remember this. We have the part, the whole, and the multiplier. So for example, we're going to take the part divided by what? The whole times what? The multiplier of 100%. And that'll give us what? Our answer. So in preparation for the exam, please make sure you understand percentages and also understand frequency and percentage. Let's move on to the next lesson. Inferential statistical methods. Let's talk about why this is so important. When it comes to making inferences and using statistics, this is the method we want to use. So for example, we may take surveys, we may run samples, and because of that, we want to make an educated guess that's backed by some data. So when we consider inferential statistics, we're going to use these to answer questions such as, what is the average income of all adults in the U.S.? Or what is the average test scores of boys and girls? Or does olive oil improve lifelong longevity? These are questions we could ask and get answers to using what? Inferential statistics. So some of the tests we could use are listed here. We have the t-test, z-scores, p-values, and chi-squared. Now, in preparation for the exam, I'm going to ask you to please commit to memory these four methods and understand how to apply them. So t-tests we're going to use to compare the means of two groups, whereas we're going to use z-scores for what? We're going to compare across populations in a test or sample. So when it comes to methods and using samples, we also want to consider hypothesis testing. This is where we're going to use data from a sample to test a specified hypothesis. Confidence intervals is a little different. This is where we're going to use data from a sample to estimate a population parameter. For example, what is the income level? Or what is the education level? Do they have bachelor's degrees? What's the average number of masters? These are things we could ask using intervals. Regression analysis. This is where we could look at the relationship between two or more variables of interest. Now, ANOVA, this one here can be confusing, but this one is very common, and we're going to want to use this when we have independent variables we could use to analyze the difference between two or more groups. So basically, if we have 3 or 4 groups of basically samples we want to look at, this is a great test we could use. With that said, let's move on to the next lesson. In this lesson, let's talk about hypothesis testing with Excel. Now, we want to understand first hypothesis testing and some of the measures we could use and some of the approaches and options that are available. I'm only going to cover just what we need to know for the exam. Be aware there's a lot more that we could talk about, and processes and workflows and how to actually perform it in Excel and all of these different options that might be available. So with that said, we want to be aware that the p-value is what we're going to use to determine the likelihood of the null hypothesis. This is basically a way, when we say null hypothesis, we're basically saying that there's no significant difference. So if we come out with the measurement over here of 20, and we have 20.5 over here, that is generally considered not significant. P-value is what we would use to determine if a hypothesis is true or not. So we need to understand the p-value ranges, which are 0 to 1. So we could use Excel to do this in most cases. It is actually quite widely used to, for example, to just calculate simply the p-value. And we could also use what's called the t-test as well. This is a function that's built in. Now we do need to have the analytics package installed in Excel, and I'll talk about that at the end of the module. Now, when it comes to statistical measures with Excel, Excel does have built-in functions for calculating the p-value. That would be the t-test, the z-test, what's also known as chi-squared, so the CHISQ, that's chi-squared, and the f-test as well. When it comes to the most common method of calculating p-value in Excel, we're typically going to want to use the t-test. It's the simplest and most direct, and in most cases will do the job. Now, a p-value of less than 0.05 is considered typically significant. So, in other words, we can reject it, but we may not. Once again, it's really up to you as a data analyst to determine what is significant and maybe what is not. You'll need to identify that. So when we look at p-values in Excel, then this is something we do need to know for the exam, is understand if we get a p-value, we need to look at that p-value and be able to determine on the exam, is it significant, is it marginally significant, or is it highly significant? Now, when we consider the p-value, let's say, of the third one down, 0.05, that would be considered significant. On the other hand, if it's 0.10, it would be not significant. Again, these are values that we, of course, as a data analyst can determine, is this going to make sense or not in our situation? But for the exam, these are the p-values that are used in Excel that we'll want to know. Now, what about errors? So we have two main types of errors we want to be aware of. That would be the type 1 and the type 2. So type 1 is when an error occurs and a null hypothesis is rejected. In other words, null hypothesis being what? This is when the results are not significant. On the other hand, a type 2 error is going to occur when a false null hypothesis is not rejected. So it's the opposite. And lastly, for us to be able to use Excel to run our hypothesis testing, we need to have what is called the analysis toolpack. Now, to find this, we need to go to Options in Excel, then select Add-ins. You'll see that the toolpack in this case is installed, but to be able to make sure it is installed, validate that the add-in is checked off, and then save it as OK, and that's all you should have to do. With that said, let's move on to the next lesson. Linear regression. In this lesson, let's go to a whiteboard and discuss some of the main concepts and terms related to linear regression. Linear regression. In this whiteboard, what I like to do is walk you through a quick example, but also talk about some of these terms as well, because this will be a really challenging area for people that may be new to data analysis. And so understanding these terms and understanding the high-level concepts is very, very important. Now first, let's talk about linear regression. What is it? When we look at linear regression, this is a data analysis technique that we could use to predict the value of an unknown data point by using another related data point, in essence. Now, with linear regression, we want to use this to estimate the relationship between two quantitative variables. In this case here, I want to answer the question of when someone is a certain age, what would be the common number or average number of dogs, let's say, that they have? So as we get older, we want to determine, is it really true that we'll likely have more dogs when we get older? Now again, that seems like a really simple question to ask, and a lot of this could be really subjective. However, we want to sample the data and see if there's any correlations. Is there any cause and effects to look at? Now, with simple linear regression, we want to use this when we understand the following. First, we want to know what exactly is a relationship between two variables. In other words, what is the relationship between dogs and then the age of a human? We then want to also consider the value of the dependent value at, for example, whatever value that's set. So, for example, when someone's 50 years old, is it fair to assume that they're going to have 2 dogs on average? Once again, just a really simple example. We could also look at, just as a simple correlation, what exactly would be the income of specific zip codes, or what would be the income for specific age groups in a zip code. So just whatever we want to use this for, and we have an unknown value, but we have known values we could use, then we could go ahead and use linear regression in a lot of cases. Now there's a lot of different models, but when we consider a regression model, the goal is to describe, for example, what is the relationship between variables by providing what is a line, really. So what we're doing is fitting a line to the observed data. If the data we collected says that anyone that is 40 years old may or may not have 2.5 or 3 dogs, let's say. Again, I plotted this out really quickly, but just as an example to show you how we correlate this. So we want to use what's called a straight line. That is what linear regression uses in the model. So be aware that we need to have straight lines for this to work. Now, non-linear regression models will use what? A curved line. So if it's linear, it's going to use what? A straight line. If it's non-linear, it's going to use what? A curved line. Now, when we consider correlation, this is a relationship between 2 or more equal values. And it's important to note that correlation does not equal causation. This is basically saying that just because they're equal does not mean that they're really directly related to the input or output, or basically what we want to look at is really being the relationship as being quantitative or equal or related. Now there's another correlation term I want you to be aware of, and it is called the Pearson's correlation coefficient. This is known as the R value. This is what we use to measure the linear relationship between data points. So we're going to have our data points laid out here. And so, for example, if I go over here and I go to where is my icon finder, I could go and just say, for example, a dot in this case, and I could plot it out here as needed. Again, really straightforward example. And so when I do that, that is helping us plot out the R value. So what about the R2 value? This is a squared R value that we're going to use in typically a percentile. So if we have a correlation of 1, this means 100% correlation. Now, when we think about correlation, remember we can have positives and negatives. And in the lesson that we talk about correlation in more detail, we'll get into that when it comes to really understanding the details. So just be aware, I'm going to glance over this for this whiteboard. And then we need to know about inferential statistics as well. Inferential statistics. So this is really where we use statistical methods to come to a conclusion. Now, let's say I have data here for up to age 60, but I don't have data for age 70, or I don't have data to really show more than 5 dogs. But I have enough data or experience, or I've surveyed enough people to come to the conclusion that I can infer that as people get to age 70, that maybe they have less dogs. Again, this is certainly not going to be something I want to insinuate may be true, but I may come to that conclusion at this point based on like what I know, or what I've observed, or what I've surveyed. But I don't have the hard data to back it up. Just one simple example. So when we prepare for the Data Plus exam, it is so important that you understand these terms and be aware of how we can use quantitative variables to really predict the value of an unknown value. That is linear regression. Now, the formula for linear regression is, again, y equals a plus b and x. So remember, we're using the y-axis here, and then the x-axis here. And for the Data Plus exam, we do need to know this formula. With that said, let's move on to the next lesson. Analysis testing. In this lesson, let's go to a whiteboard discussion and walk through some of the techniques that we'll want to apply when it comes to testing and really understanding our analysis approach that we use in our day-to-day activities as a data analyst. Let's move on to the whiteboard. When it comes to looking at data and trying to derive value from that data, we need to walk through typically an analysis technique. And so as a data analyst, you'll likely need to understand not only where the data comes from, but how you could actually determine the right analysis approach, what are the business requirements, the tools that you could use, etc. So let's talk about a very common high-level analysis technique that you can consider in your day-to-day activities. Now let's say we receive data from a school district. That data from the school district has enough information for us to bring that data in and to look at the age group, the grades, the level of classes, determine demographics, the scores of tests or whatever the school district is providing us. So if we receive that data, we first we want to understand what are the business questions we have to answer. For example, let's say the district goes, what exactly is the correlation between demographics and scores? Or what is the trend for scores from, let's say, from elementary school to middle school? Or are there specific schools that do better than other schools? So we need to compose the right questions to be able to answer them correctly. We then want to collect and store the data as needed, and then we prepare the data after it's cleaned. Then we need to analyze it and then visualize the data. So when we look at all of those things we have to do, the first thing we need to do is to really come together in what's called a brainstorming session. We need to understand what the customer needs and understand how we're going to provide that to them. And that's all really approached from this high-level process. Now, we need to determine analysis. We need to look at, for example, trends in this case, just as a simple example. Now, there's three different types. We have geographic, temporal, and what is really referred to as intuitive. Now, when we look at geographic, that really just says that we're going to analyze the trend that's typically, in most cases, within a user group, and it's defined by a geographic area. So in this case, it could be a zip code. It could be a, city, or even just a neighborhood, whatever that geographic location is set as. Now, temporal is when we analyze a trend typically within or even across user groups defined by a time period. And so instead of like a geographic approach by zip code, we're looking at it over, let's say, 1 year or multiple years or a semester, let's say, whatever that time frame is. And then we have intuitive. So intuitive is perhaps the more difficult approach to use in the sense that we have to really rely on not have a bias. We have to rely on the knowledge of specific types of data. It's generally considered the most difficult when it comes to trend analysis. But generally with intuitive, this is when we're going to look across the user group based on a logical explanation, behavior patterns that we could come up with as an example. Now, when we consider intuitive, let's just say we have an issue at the school where it seems at certain points of time in the year that students miss more days of school than others. Well, there may not be anything that we've collected in the data to assume that it could be that people are getting sick more often, or it could be the holidays, or whatever that assumption is. Now, there's also exploratory performance and link that we could look at as well. So we've come up with a type of analysis. The next thing we want to do is go over here and look at the questions. Come up with the questions. If we don't already have them, identify what they are and really try to come to a conclusion on how we could really apply the business requirements that were given and answer these questions. Then we also need to make sure we understand the scope and the objectives, because this is where we need to determine as well down the road at the end on whether or not we met that gap analysis or we actually performed within the scope. The next thing we then move on to is to look at the data. So what are the data needs? This is where we analyze it. We can look at auditing. We can profile the data. Now, profiling data is what? This is when we're going to dive into the data, look at what it is, look at how it's structured, the schema, whatever we have to look at. We then can look at validation and look at data cleansing as well. So for example, with cleansing, what is that? That's where we're going to remove any kind of redundancy or unneeded data. Then after that, we're going to move on to the tools. So we may need to look at, do we use Python or do we use R, for example? Whatever languages we need to use, then this is where we want to determine that. Then what about tools? So do we use, for example, tools such as Redshift? What do we use? Then visualization. So this is where we need to determine how we're going to visualize our data. This is typically part of the tools process. So for example, do we use Power BI? And then once we've gone through all that, we have our data, we've analyzed it, we visualize the data, we then can look at the fact, does it answer the questions? Do we actually meet the requirements? Do we go within the scope of our tasks? This is really where we want to come to a conclusion in effect. And lastly, for the CompTIA Data Plus exam, be aware that we're going to be challenged in some of the questions and really understanding what do we perform first? Do we look at the type of analysis? Do we look at business requirements? What about the data needs? What about the tools and visualization? Well, it makes sense that visualization should come after the tools and determining what we use, but it definitely needs to come after what? After we analyze the data. Does it make sense to visualize data until it's actually cleaned and validated and profiled or audited or whatever we have to do? So with that said, let's move on to the next lesson. Module summary. Let's go through a short review of what we covered in the module. We talked about descriptive statistics, and we understand that this is a method we could use to summarize, describe the features of specific data sets. We also learned about tendency and dispersion, and we learned about how we would use them in our data analysis processes, workflows, etc. We also talked about what measures of central tendency is. So it's a way we could basically provide summary statistics that represent a center point. Measures of dispersion use variance, standard deviation, and range. Frequency is really the number of times that the value appears. Percentage is the frequency divided by the total number of values in the data set multiplied by 100%. Now we of course can measure percentage change, percentage difference, and confidence intervals in our data analysis tool set. There's a number of different ways we could do that. We also learned about inferential statistics. This is a way we could make inferences based on the data that we have. This is done via typically population samples. Now we know that Excel has built-in functions for us to calculate any number of values like a p-value. We could run a z-test, chi-squared, etc. And lastly, the most common method of calculating p-value in Excel is through the use of a t-test. With that said, let's move on to the next lesson. Module review questions. Let's go ahead and test our knowledge. Microsoft Power BI and Tableau are programs that are capable of creating powerful visuals and can also interpret data and help us do that for that matter. What do we call the pane of glass we would view this data through? That would be a dashboard. You have conducted a data analysis on a specified data set and have come to a hypothesis. What is the test that you can perform to determine if that sample follows a normal distribution? That would be a goodness of fit. Which of the following measures of central tendency would you want to select if you need to provide a customer with the average of a set of numbers needed for a pricing point of a product they sell. Pretty much, you'd want to know the mean. Remember, this is the average of a set of numbers, and we would find that by what? By looking at all the numbers in that data set. Now, for the Data Plus exam, it goes without saying, it is going to be interesting for someone new to the world of data who doesn't exactly know on top of their head the difference between mean, median, mode. For example, those three can be very confusing, especially if you don't have it memorized. So please make sure you know those three. You will likely see these definitions on the exam more than a few times. Okay, which of the following tools would you want to use to transform data? Now, be aware, transforming data, not visualizing data, not ingesting data, that would be RapidMiner. Now, RapidMiner is a free charge open source software tool, very widely used, and certainly something you may have used if you're a data professional. So, with that said, let's move on to the next module.